Takeaway time. Tim, take us away. Takeaways.
Try to keep this tight. We started off with, AI agents context. We have no guess around that. And we started off by saying, hey, there's certain things that you do now. Just apply all of this, especially today, because agents are a wrapper around an LLM API that can send requests to different services. You can put it in a reasoning loop. It can call other agents. It can have deterministic code that's part of it, and it's taking action, right? And so I actually felt that was a very practical definition around agents and very useful, I think, for folks who sometimes hear more pie in the sky kind of definitions for things. And you said that there's kind of different kinds of agents, and it's all a bit of a mix of art and science. There's coding agents, which are more, your VS Code, your GitHub Copilot, and things like that, which are helping to program. You've got building agents into products, which is more, kind of code calling APIs and these loops and things like that that are more around interacting with products and data services. People are doing both, and they both have similar problems, but they also have different problems as well. And we started off by saying, okay, well, if you want to do these, how do you make them effective and reliable? What are people kind of doing with these different kinds of agents? And starting with, building agents, which was the second set of agents we talked about. You've got like agent builders, which are more of a visual style. You've got agent frameworks, which is kind of, Lang chain and all of these different things that you can build agents with. And in general, kind of the biggest feedback around them is experiment, play, try them out. Like, this is the best way to kind of learn how to interact with agents and build agent products. With that, Juan, over to you.
Yeah. So when we get into context, it's great that we were separating this coding and the building agents. So when it comes to coded agents, when you spend a lot of time prompting, after a while, it starts to get worse, right? That means that the more context we have, it doesn't result always in just get better results. So instead, this is really about writing a coding spec that tells your agents your intent, and the coding agent does that. But your spec isn't always right. So what you really need to think about is like spending most of your time thinking about your spec and split into manageable tasks and what is done by each piece, versus instead of fixing that code that was generated, right? So you want to try to manage the spec and manage all these subtasks. And when you get good at fixing the specs, it's much more faster than fixing the outputs. And then when it comes to the building agents, a lot of these inputs are coming from chatbots, from people that you don't even know what those actions are, but you don't have a visibility all the sequences of tools are going to be called and how it's going to reason around this. So you need to really start doing evaluations with real users' data and inputs, right? And compare the outputs of the LLM to what you expect the answer to be. So if you can't afford a single mistake, then probably you shouldn't be leaning on LLMs, and you need to lean on the more deterministic approaches, because if you start to plug in so many tools, this is going to get more confused. And then we kind of closed with the whole reliable AI. And at the end of the day, as the owner of the problem that you're trying to solve, like, what success looks like. And remember, AI is just a tool, and you can be already solving that problem with other tools too. But so you have that baseline. And so you understand where mistakes can happen and what those mistakes could be and what those risks are. So you need to understand the risks for those use cases. So select by your top 1, 2, or 3 different things that you want to bring AI into. Don't focus on the risky ones, and evaluate to see if the results does fit your reality. And for this, you will need to have domain experts around that. And if you're unhappy with the results, that's when you improve with the context. And that's where, especially when you're bringing extra data, you're investing into data semantic infrastructure. And that's why a semantic knowledge graph is going to be critical for that. And we talked a little quickly for small agents, small models. And so we can do a lot with small specialized models, especially when you need low latency, put them on the edge. For example, real-time physical AI needs that.
That's a great summary.
All right. Anything we missed?
No, I think this is great.